Okay, so today we're going to do an introduction to counting and probability. So first, my name is Gopal, and I'm a rising sophomore at DuPont Manual, and I've done math counts and and I've done math counts AMC and have participated in AIME in the past. So
Yeah. Hi, my name's Yolanda. I'm also a rising sophomore at DuPont Manual, and I've done math counts for all 3 years of middle school and participated in AMC 8. Okay, so this week we're going to have a point system and just have a fun competition between all of us. Okay, so Gopal is going to explain how it works.
yeah, so if you were in my algebra class last week, it's going to be like the same thing. Uh, we're going to have like questions, right? So when we're doing questions, the first three people to answer will get like okay, yeah. You guys did have this. Okay, so it's going to be like really the same thing. So the first three people to answer will get like a point. And then if you volunteer to explain how you did the question, you'll get an extra point. And so it's going to be the first three people that answer. And then on Jamboards and stuff, the amount of questions you answer on the Jamboard will dictate the amount of points you get for that Jamboard. And so it'll so I can so I can explain it as we go on. Like you guys will see like where you get points and how it works. The more questions and stuff we do together.
Okay, so with that, let's get started. So I'm sure you all know how to count. Maybe you count sheep when you're going to sleep, but in AMC, counting is a bit more complex than just going like 1, 2, 3. It's a tool that we're going to use to solve many problems, a lot of different problems. So today's topics, we're going to learn how to count the number of terms in a sequence, the fundamental counting principle, and we're going to introduce you guys to probability along with different types of probability.
So all right. So the first question. So find the number of integers between a 1 and 11 inclusive. So if we use our fingers and we count, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we realize that there are 11 numbers instead of 10. It's not just 11 minus 1 because both at the end, because both the 1 and the 11 are being included, there's actually going to be 11 numbers, right? And now we're going to have a little harder example. About 4, 5, 6, all the way until 53. How many numbers are there? It's not going to be 49. It's going to be 50. So you might think that the answer is 49 because it's like 53 minus 4, but this is actually incorrect because again, the 4 and the 53 are going to be included. And if you want to count with your fingers again, you can. But you're going to see that it's going to be 50 terms. Yeah, so a trick that you could have used here is if you subtracted 3 from every term, you would have got the sequence 1, 2, 3, 4, 5, all the way until 50. And you could have seen that there were 50 terms, right? So this is known as an off by 1 error. And you basically, to calculate the amount of terms in like a sequence where it's like 1, 2, 3, 4, 5, or like it's increasing by 1, you want to subtract the smaller number from the larger number to find how many terms are in a series of numbers. But you'll get something, but it'll be off by 1. So how many numbers are in between 49 and 61? Yeah. So the answer here is going to be 13, right? Because again, if you count, 61 minus 49 is 12, but that's going to be off by 1. And this is because like when we simply subtract 61 or 49 from 61, we leave out one of the end numbers, and this is called an off by 1 error. And usually these are pretty simple, but once you get into the habit of like recognizing that it's off by 1, usually these kinds of mistakes will go away. So you want to be careful about off by 1 errors.
Okay, so let's move on to some example problems. Try to find the number of integers in between these. And also, they're inclusive, so that means that they include both of the numbers. So the first problem, you have to include 12 and 1,245. Okay, so go ahead and try the first one, and then put your answer in the chat. And if you want to explain, like indicate that in the chat as well, and I'll call on one of you.
Oh yeah, these questions are going to be worth points, by the way. So
all right, so Charles's process was to do 1,245 minus 12, and then he added 1 to fix the off by 1 error. So his answer was 1,234, and a bunch of other people also got that. So nice job. And now moving on to number 2. Okay, so Santoshi, you were the first to answer that one. Do you want to explain how you got that answer for number 2?
So I subtracted 13. Well, no, I subtracted 12 from each thing, and then I added 1, and that gave me 98. Not 98, 32.
Yeah, okay, great. Okay, so moving on to number 3. The number of integers in between 81 and 178 inclusive. Okay, Shreya, do you want to explain that one?
does anyone at all want to explain that one? Like how they got it?
Yeah, okay. So in the chat, she says 178 minus 81 equals 97. Then you add 1 to fix the off by 1 error to get 98. Okay, so I don't think we really need to do the explanations for 4 and 5, but go ahead and put your answers. So what did you get for 4? Yeah, correct answer is 52. And then what about for 5? Great, 112. So it looks like all of you guys are getting how to solve these sorts of problems.
Yeah.
Oh yeah.
Are there any questions about solving these kinds of questions or what an off by 1 error is? Because this is these are kind of the fundamental, or this is kind of one of the fundamentals of counting. And if you don't understand this, understanding everything else in the class will probably be a little harder. Santi, I don't think I understand what you're saying. All right.
I was actually unmuted.
Oh, okay, that's fine. So, 1 second. All right. So now let's pick up where we left off on counting terms in a sequence. So we're going to do a little more complex examples now. So how many multiples of 3 are between 3 and 81 inclusive? So think about what operation you could use on all the terms so that you can make this question easier. Or like turn it into a 1, 2, 3, 4 kind of thing. Wait, how did you get -2?
I guess I can,
Oh, subtract 2 from each number?
but that's not right.
Well, that's a good idea, but then if you subtract 2 from every number, you'll just get 1, 4, like 7. And that isn't that much easier to count. Oh, dividing by 3 each number. Now that's a good idea. So if you divide each number by 3, you're going to get 1, 2, 3, 4, all the way until 27. And now this just turns it into something that we've already seen before, we've done. And the answer here is going to be 27. So think about like clever ways to do operations like this to make the questions much easier. This is called, I think this is called a one-to-one correspondence, but you don't need to know that.
All right, so let's do some practice. Find the number of terms in the following sequence. So let's start off with number 1. And as always, put your answer in the chat. Okay, so a bunch of you guys are saying 11. Now, also put in the chat, what operation did you use? Yeah, so you identified that all the terms were multiples of 4, and then if you divide everything by 4, you just get the simple counting sequence from 1 to 11. And then you can tell there's 11 terms. Okay, next one. This one's going to be harder, but think, see if you can spot a pattern in it. Okay, Charles, do you want to explain your process since you got it first?
Yeah, I immediately noticed that these are all squares, and the top one, 81, is a square of 9. So that means there's 9.
Right, so it's just going to turn into 1 squared, 2 squared, 3 squared, 4 squared, all the way until 9 squared, and then it's just going to be the 1 through 9. That's just going to be 9 terms, right?
All right, so this last one is the hardest of all. You have to do 2 steps here, but you want to try to reduce it down to like the basic sequence 1, 2, 3. Okay, so try and figure out how you would do that. Yeah, so for this one, like Charles is saying, you should first subtract 1 from all the terms, and then it basically turns into something similar to number 1 and then you divide everything by 4. So then your terms turn from like 1, 2, 3 all the way to 12, and then that's 12 total terms. So here are some more of the explanations. I'll give you a few seconds to look at them if you want.
Okay, so the fundamental counting principle. The fundamental counting principle basically says that if there's one event that has like m possibilities and then the other one has n possibilities, and together you just multiply the amount of possibilities that both of them have for the total. And so it's kind of like, I think most of you guys already know this, but like it's just going to be multiplying the total of possibilities together for each event. So for example, we're going to have our first question. You have to choose one t-shirt out of 10 different t-shirts and one pair of shorts out of 6 pairs of shorts. So how many combinations of a t-shirt and a pair of shorts can I wear? Right, so this is almost a direct application of the fundamental counting principle or whatever. And basically there's 10 possibilities for the first event, or like the amount of shirts. So there's 10 different shirts, and then there's 6 different shorts. So it's going to be 10 times 6. There's 60 possible shirts. There's 60 possible shirts and short pairs or combinations that you can have. So this one's almost like a direct application of the fundamental counting principle.
Okay, so next one. Sam rolls a fair die and flips a coin. What are the total number of outcomes that can come from that? So put your answers in the chat. Yeah, so all of you guys are saying 12. And like Sanvi explains, so we know that the dice roll can have 6 different outcomes. And it says that it's a fair die, so that makes sense. And the coin flip can give us 2 outcomes, either heads or tails. So using the fundamental counting principle, we multiply like the possibilities for the first one, which is 6, by the possibilities for the second one, which is 2. So that gives us 12 possible outcomes.
Okay. So now we're going to do some practice questions. All right. And these are going to be worth points. So Melody has 3 different shirts, 2 different pairs of pants, and 5 sunglasses she can wear. If she wants to pick one shirt, 1 pair of pants, and 1 pair of sunglasses, how many outfits can she choose? All right. So okay. So 30 here is going to be the correct answer. And it's because there are 2 pairs of pants and 3 different shirts, 2 pairs of pants, and 5 different sunglasses. So it's going to be 3 times 2 times 5. And that's going to be equal to 30. Right? 5 coins are flipped, one after another. How many different combinations of heads and tails are possible? Oh, think about it. Okay. So we have a divide here. So 2 people think that the answer is 32, and 4 people think the answer is 10. So does anyone want to volunteer and explain why they think the answer is 10 or why they think the answer is 32?
Can I go?
Yeah, sure.
Okay, well, the probability of getting heads or tails on any coin or any fair-sided coin is 1/2, or so you have 2 possibilities. So if you have 5 coins being flipped, it would be 2 times 2 times 2 times 2 times 2, because each of those possibilities multiplied by.
So that was, yeah, so that's right. That's a pretty good explanation. There are 5 different coins here. And there's 2 possibilities for a coin, and then there's 5 different coins, but it won't be 2 times 5 because a coin because it's going to be the event is actually what's going to be showing up on the coin, not like the actual coin itself. So it's not going to be 2 times 5. It's going to be 2 times 2 times 2 times 2 times 2, or 2 to the power 5, because for each coin, for each of the 5 coins, there's 2 possibilities. So you're going to be multiplying those different events together. So so you'll be multiplying the 2 5 times. You'll get 2 to the power 5. A secret code is made up of a letter, followed by a digit, and then followed by a different letter. How many secret codes are possible?
All right, so this one's a bit trickier. Think of how many letters there are, how many digits are possible, and then how many different letters, like not that they have to be different from the first letter. So how many possibilities would be different from that possibility, and then multiply together.
Also remember, 0 is a digit, a possible digit. Okay, I'll wait for a few more answers. Okay. So, all right, so the answer here is going to be 6,500. And that's because for the first letter, you have 26 possibilities, right? A through Z, so there's 26 letters. And then you multiply that by the amount of digits there are, and there are 10 digits, not 9 digits, because remember, 0 is a digit. So 0 through 9 are the possible digits there, so it's going to be 26 times 10, and then you want a different letter from the first letter, and so you can't pick the same letter again, so basically it's going to be 25 letters instead of 26 that you can choose. So 26 times 25 times 10 is going to give you 6,500. Are there any questions about this or number 2? Okay. A last question, or for this section at least. How many phone numbers can be made if the first digit has to be non-zero? And okay, and these are going to be 10-digit phone numbers, okay? Not like international. Sanjay, you're close. Should have a- Okay. Okay, so the answer here is going to be 9 followed by 9 zeros. And this is because the first digit has 9 possibilities, then the digits 1 through 9, because the first digit has to be non-zero. So it has 9 possibilities, which are the digits 1 through 9. And then you multiply it by the amount of possibilities for the remaining digits. And since it's 10 digits, it'll be 10, you'll be multiplying the 10 9 times for the remaining digits. So it'll be 9 times 10 to the power 9, or 9 followed by 10, or 9 followed by 9 zeros. Yeah. All right.
Okay, so the second concept we're going to learn about today is probability, which you guys may have already heard of, but basically the core of probability is just writing desired outcomes and then dividing that by the total number of outcomes that you can have. So as its name suggests, probability is basically the chance for something to happen. So like a value of 1 means like something is 100% going to happen. And a value of 0 for the probability means that something is impossible. It's never going to happen. And a value of 1/2, like flipping a coin, means it's equally likely to happen or not happen. So probability is always going to be a number between 1 and 0 and inclusive. So it can be 1 or 0. Let's look at an example of how to find probability.
So if I have 11 socks in my drawer, where 7 are red, 2 are green, 1 is blue, and 1 is yellow, what is the probability I draw a red sock? Okay. The answer here is going to be 7/11ths, or 7 over 11. And this is because our total, remember, probability is just going to be our desired outcome over the total number of outcomes. And so there are going to be 7 red socks, so 7 successes divided by 11 total, or the 11 total socks in the drawer. So the answer is going to be 7 over 11, right?
Okay, so what exactly does 7 out of 11 mean? Well, since it's greater than 1/2, this means like you are pretty likely to pull out a red sock compared to like the other colors, because it makes sense since there's most of the socks in the drawer are going to be red. And just remember, all probability can be simplified to desired outcomes divided by total outcomes. Okay, so we're going to try another problem. Joey loves going to a frog pond. There are 200 frogs and 19 frogs are pink. So what is the probability that if he randomly grabs a frog, it's going to be a pink frog? Yeah, so pretty simple, right? There's going to be 19 desired outcomes, which are the pink frogs, divided by the total number of frogs, so 200. And then you would simplify that fraction as possible, but you can't simplify that here. So our answer is just going to be 19 over 200. So nice job. Okay, so now we're going to do some practice. So there are 4 blue pebbles and 7 red pebbles in box A. There are 3 blue pebbles and 5 red pebbles in box B. If Charles, why do you like pebbles so much, Charles, pulls out a blue pebble, then he will win a prize. Which box should he pick the pebble from to maximize his chances of success? So basically, which box gives them a better chance of pulling out a blue pebble? Yeah, so for box A, the probability of pulling out a blue pebble is 4 over 11, because there's 11 total pebbles. And then for box B, it will be 3 out of 8, because 3 blue pebbles over 8 total pebbles. And 3 over 8 is greater than 4 over 11. So you should pick from box B. You guys are correct. Right now, Sai is frustrated with the math problem, and he randomly types a 3-digit number into his calculator. If the correct answer is a 3-digit number, what is the probability that Sai's answer will be correct? So with this, you can actually use our off by 1 error, counting the number of terms in the sequence to help you with this, to figure out the total possible outcomes. But oops, let's see what you get. Okay, Charles, since you're the only one to put an answer so far, do you want to explain how you got that?
Yes. Okay. So it says the only correct answer is it's a 3-digit number. It's one 3-digit number. There's 900 3-digit numbers, so it's 1 out of 900.
Okay, and how did you get 900 3-digit numbers?
Well, I mean, I've known that 900. There's been 900 3-digit numbers, but you can do for the first digit. There's 9 possibilities, and there's 10 afterwards. 9 times 10 times 10 is 900. 1 out of 900.
Yeah, great. So you are absolutely correct. It is 1 out of 900. And another way to find the total number of 3-digit numbers is to use our counting strategy. So there's 100. The 3-digit numbers range from 100 to 999. So basically, if we use our counting strategy, we subtract 99 from each of them, and then we get 1 to 900. And then that tells us there's 900 terms.
Okay. Independent probability. Oh, 1 second. So independent probability is the probability of two events, or more than 2 events, that don't have an effect on each other's outcome. So to find the total probability from 2 or more independent events, we multiplied the individual probabilities together to find the total. All right, so this is kind of like what we've been doing so far. So the independent probability is a probability that, right? So we just said that. So what are some events whose outcomes don't affect each other? So think about it. So everyday examples of events whose outcomes don't affect each other. like it doesn't have to be from your life. Maybe like think about things that think about something from like outside, like maybe weather or something, for example. Or it can be like oddly specific for some reason. Like just think of some events that don't affect each other.
So I'll give you an example to get you started. So for example, say you're flipping like a coin, you're going to get either heads or tails. And then if you flip that same coin again, you're still going to get like heads or tails with a 50% probability. And so they don't affect each other. If you got heads one time, it doesn't matter for the second one at all.
All right, roll dice. Okay, that's a good example. Anything else that anyone can think of? Yeah. By the way, if you think about it, counting and probability, which is actually a relatively new branch of mathematics, has the most practical use in life, or like modern day life. Like for example, I know a lot of people that say like, oh, you don't use math in real life at all. Like I'm not going to use trigonometry or something in real life, but counting and probability is actually used a lot in real life. And mostly it's not used for the greatest purposes. Like counting and probability is used in like casinos and stuff to trick people and make money, but it has the most real life or like practical use scenarios out of all of the different branches of math. Okay. So I don't see anything else, any other people volunteering in the chat. So some examples of events whose outcomes don't affect each other. So like, for example, one of them, it said roll dice, right? That's a choosing a random t-shirt. Okay. When are you? Right. So yeah, so choosing a random t-shirt, I guess that, yeah, okay, that might be one. Rolling dice is also an event whose outcome doesn't affect each other. All right. Okay. Next slide.
Okay, so we're going to do an example of independent probability. So Penny flips a coin 5 times. What is the probability that she lands 5 heads?
Okay. So I see a 1/32. And that is going to be our correct answer. So the answer here is going to be 1/32. And this is because the remember that this is independent probability and that each of the each of the outcomes don't affect each other. So there's a 1/2 chance of flipping a heads with your first coin, and so then there would be a 1/2 chance of flipping heads with your second coin, and then the same for the third, same for the fourth, and then same for the fifth. So it's going to be 1/2 times 1/2 times 1/2 times 1/2 times 1/2, which is going to be 1/32. Okay. Example 2. If the chance of rain today is 1/3 and the chance of rain tomorrow is 2/5, what is the probability that it doesn't rain today or tomorrow? Assuming the events are independent. Remember, if this, you're going to be multiplying the probabilities, not adding. Okay. The answer here is going to be 2/5, and this is because there is a 2/3 chance that it doesn't rain tomorrow, right? And that's because there's a 1/3 chance it rains today. So the chance it doesn't rain is going to be 1 minus 1/3 or 2/3. So, and then the probability it doesn't rain tomorrow is again going to be 1 minus 2/5, which is 3/5. And so then you're going to get 2/3 times 3/5, which is going to be 2/5 chance that it doesn't rain today or tomorrow. Okay. Are there any questions about that example? Oh, okay. All right. Okay, I guess there are no questions about that example. Right.
Okay, so moving on to example 3. John flips a coin 100 times in a row. On the first 99 flips, he goes on such an unlucky streak and flips tails every single time when he wanted heads. Okay, so what is the probability that John will flip heads on his final toss? All right, kind of a trick question, okay? Yep, but it looks like you guys aren't getting tricked. So the probability here is still going to be 1/2. Like the final toss is completely independent from the other tosses. So it doesn't matter that he flipped tails the first 99 times. It's still going to have the probability of 1/2.
Right. So I think I forgot what this is called, but this does have something to do with gambling.
Oh yeah,
And
gambler's fallacy.
yeah, that's what it's called. But basically, like, people would think that what if they like there would be like some gambling like games, and where they think that if they drew like they would put down like a certain amount of money as soon as somebody goes like 9 heads in a row or something, and then they would put down a certain amount of money because then it would become really improbable for them to get 10 heads in a row. But in reality, it's going to be the same probability that they get heads again.
Yeah, like you think you flipped it 99 times and it's always tails. I have to get heads on this final test, but no, that's not really the case.
It's going to be the same probability as it was for the first 99 rolls or first 99 flips. It could just land straight up, and it would be both heads and tails. Actually, is that even possible? I wonder.
I mean, it's never happened to me, but I don't flip all that many coins.
Okay, so now we're going to do some practice with this. What is the probability of rolling a 4 on a die and then rolling a 5? Oh, these questions are going to be worth points, by the way. Again.
Okay, so the correct answer here is 1/36. So we have like 2 different events here, rolling a 4 and rolling a 5. So you have to find the probability of rolling a 4 on a die. Well, since there's 6 different numbers on the die and like only one of them is your desired outcome, that's 1/6. Then the chance of rolling a 5 is the same thing. It's also going to be 1/6. And since this is independent probability, you have to multiply the probabilities together to get 1/6 times 1/6 equals 1/36. There's a 1/3 chance of it raining today and a 1/4 chance of it raining tomorrow. So what is the probability that it rains both today and tomorrow?
Okay. And the answer here is going to be 1/12. And that's because there's a 1/3 chance that it rains on the first day, and then there's a 1/4 chance it rains on the second day. So it's going to be 1/3 times 1/4, and that's going to be equal to 1/12, or the probability of it raining both today and tomorrow. What is the probability of not rolling a 6 on a die and then flipping heads? Remember, they're asking the probability of not rolling a 6, not rolling a 6. So you want any number except 6. Right. So the answer is going to be 5/12. And this is because the probability of not rolling a 6 is going to be 5/6, right? Because you want any number except 6 is fine. And so there are 5 total. So there are 5 possibilities, or like 5 desired numbers that you can get over the total of 6. So it's going to be 5/6 probability of not rolling a 6. And then you multiply that by the probability of flipping a heads, or 1/2. So 5/6 times 1/2 is going to be equal to 5/12, or 5/12. Are there any questions about independent probability? Or any questions so far about anything?
Okay, so let's continue on to dependent probability, which is the probability of 2 or more events happening, and those events do affect each other's outcome. So if we're calculating dependent probability, we have to consider how, like, if one event happens, how that's going to change the probability of the other event. So dependent probability is based on events that rely on the outcome of another event. So what brainstorm some events that fall under this category. So Charles said in the chat, like, say you're choosing 4 distinct digits, and yeah, that would count. So like, say you're making a 4-digit number, all the digits have to be distinct. So like there's 10 possibilities for like one of them, then there's 9 for the next one, stuff like that.
Yeah, think about examples like that, where it's like 4 digits, right?
Yeah, and then the first number can't be 0, so exactly. Now weather, I suppose, yeah, in real life, weather one day could affect weather the next day, but in a lot of math problems like the ones we just did, you just pretend like that doesn't happen and just be like, it's going to rain with 1/2 chance today and rain with 30% chance the next day.
Yeah. Yeah, most math counts questions or AMC questions, weather is just a chance. It's not an actual, like, there's no relation between tomorrow's or today's weather and tomorrow's weather. It's just two independent events. But in real life, however, it's probably much different.
Okay, so let's move on to the examples.
So Jerry draws 3 lottery balls from a cauldron containing 10 balls without replacement. 5 are red and 5 are blue. What is the probability all 3 balls he draw are blue? And remember that, or actually, I don't think we said it, but without replacement means that every time he draws a ball from like the cauldron or whatever, he's not going to be putting that ball back inside. So he's going to be having one less ball every time. So the cauldron's going to be having one less ball every time he's drawing. All right. So the answer here is going to be 1/12, or mainly what matters here is the way we got the answer. So it's going to be, so the probability of drawing a blue ball first is going to be 5/10, right? Because there are 5 blue balls and 5 blue balls over 10 total balls. So 5/10 times, and then since we're not going to be replacing, so since it's without replacement, one ball is going to be, there's going to be one ball less every time. So it's going to be 4/9 this time because there are 4 blue balls. Assuming that he draws a blue ball, which is what we want, there are going to be 4 blue balls left over 9 total balls. And then times 3/8. The same story here. There's going to be 3 blue balls over 8 total balls. So 1/2 times 4/9 times 3/8 is going to be equal to 1/12 if you do your fractions properly. It's going to be equal to 1/12.
So does anyone have any questions here before we move on? Okay. Example 2. So 2 cards are drawn from a deck, one after the other, without replacement. What is the probability that exactly 1 ace is drawn?
Remember, it's exactly 1 ace. Not 2 aces.
Just as a hint, so there are going to be 52 cards in a deck of cards. So no jokers, and then there are 4 aces. All right, so how are you guys doing? This is a tougher problem, so is it like, are you guys completely confused or solving it? Okay, so we have one answer so far.
Okay. All right. Yeah. Go ahead.
Okay, so for solving this problem, we have to consider two different possibilities. First, you could draw like an ace first and then not draw an ace on your second draw, or you could not draw an ace on your first draw and then draw an ace on your second draw. So we have to calculate both of those and then add them together. So the possibility that the first draw isn't an ace is going to be 48 times 52. 48 over 52, because there's 48 cards that aren't aces and 52 total cards. Then after that, the probability that an ace is drawn is going to be 4 over 51, because we removed that first card that's not an ace. So there's only 51 total cards. And then we multiplied those two things together to get a probability of 16 over 221 for our first like possible way to do it. But we also have to figure out the second possible way. So the probability that an ace is drawn first is going to be 4 over 52, because 4 aces and 52 total cards. And then after that, there's only going to be 3 aces left in the deck with 51 total cards. So the probability of not drawing an ace is going to be 48 over 51 for the second draw. And then if you multiply those together, you get again 16 over 221. Now you have to add those together because there's 2 ways you can get what you want. And then you get 32 over 221, which is also that decimal that you can see over there.
I think this example may have been a little confusing for some people. So if you have a question about the solution, please ask in chat. Because a lot of math counts or a lot of AMC questions are going to be like this. And you're going to need to understand how to get the answer, because then when you're doing the question on test day, you'll be able to solve these kinds of questions easily.
Okay, so let's do some more practice problems.
A jar has 5 red marbles and 2 blue marbles. What is the probability that the 2 blue marbles are pulled out without replacement? Oh yeah, these questions are going to be worth points again.
Wait, so are they like pulled out like at one time, or like do they pull out one marble each time?
Oh, it would be one at a time, one by one. Okay. The answer here is going to be 1 over 21. or 2/7 times 1/6. This is because there are 2 blue marbles over 7 total marbles. So that's for our first marble. The probability that it's blue is going to be 2/7. And then 2/7 times the probability that the second marble is blue, which is going to be 1/6, because there's going to be 1 blue marble remaining over 6 total marbles. So 2/7 times 1/6 is going to be equal to 2 over 42, or 1 over 21. Okay. Example or question number 2. A jar has 4 red marbles and 9 blue marbles. What is the probability that the 2 red marbles are pulled out without replacement? Okay, this is very similar to the first example, so I think most people should be able to get it. Satoshi, remember that it's going to be without replacement, and so that there's going to be 3 red marbles left after you pull the first red marble. Sonvi, do you mean 12 over 176? Or wait, no. Oh no. So yeah. Yeah, it's completely simplified 12 over 156. Yeah. Remember that in AMC, your answers always have to be completely simplified. When they're like fractions and stuff, they have to be completely simplified. Okay. Yeah, so the answer here is going to be 1/13th, and a lot of people were able to get it this time. And this is because the probability of the first marble being red is going to be 4 red marbles over 13 total marbles. So that's going to be 4/13 times, and then the probability of the second marble being red is going to be 3 red marbles over 12 12 total marbles. So 4/13 times 3 over 12 is going to be equal to 12 over 156. And then that simplifies to 12 or 1/13th. Okay, right. 4/13 times 3/12, and then you simplify. Yeah, that's what you want to do. Okay. And then question 3. 2 cards are pulled out of a deck of 52 cards without replacement. What is the probability of pulling out 2 spades? There are 13 spades in a deck of cards, by the way. I'll give it like 2 more minutes. Remember, there are 13 spades in a deck of 52 cards. And the spades are being pulled without replacement. Okay. So the answer here is going to be 1/17. And that's because, yeah, so the answer here is going to be 1/17, and that's because 2 cards are being pulled out of 52 card or deck of 52 cards, and so the probability of pulling out a spade with the first card is going to be 13 over 52, and then the probability of pulling out a spade with the second card is going to be 12 over 51, because remember, the cards are not being replaced. So 13 over 52 times 12 over 51 is going to be equal to 156 over 2652. And that's going to be simplified down to 1/17. Okay, so, right. So I'll add points to people who got the questions.
So while GoPaul's doing that, we are going to have our 5-minute break as usual. So do whatever you need to do and then return at 10:46.
Okay.
So let's continue.
Okay.
Okay, so concept number 3 is casework. And so casework problems are basically where you just go one by one and look for like every possible solution to the problem. And you have to do it in sort of a methodical way so you don't miss a single case. But it can solve problems in a pretty elegant way.
Okay. How many numbers can be made with only the digits 1, 2, and 3, where each digit can only be used once? Oh, we never said that the digits that, remember, a number can be less than 3 digits as well. It can be 2 digits, it can be 1 digit. Remember. So remember, casework is splitting it up into these different cases and then counting those. It's just splitting up a complex problem into simpler cases and then solving for the simpler cases and then just adding it up at the end for your answer. Yeah, so the answer here is going to be 15. And we can split this up into 3 different cases where the first case is the number is only 1 digit. So that means that there are 3 possible values for that first number, 1, 2, or 3. Okay, and then the second case is the number has 2 digits. And so if we count this, we have 6 possible 2-digit numbers. We have 12, we have 13, we have 23, we have 32, we have 31, and and yeah. So there are 6 possible values there. And then the last case is the number has 3 digits, and there's 6 possible values again here. It's going to be 123, 321, 231, 213, and there's like 2 others, I think.
132.
Yeah, 132, and then
312. I don't know
yeah,
what
312. I don't know. I was just listing them randomly.
Yeah. Okay, but anyways, if you count them up, 15 values.
Right.
Okay, so this second question, I'm not gonna give you guys time to solve it, but I'm just gonna like go through and explain like kind of a strategy to make sure you aren't missing any. Because so it asks how many triangles are in the diagram below, and you can see like there's a lot of triangles there, and it'd be really easy to miss them if you were counting.
Yeah.
So what we're going
A
to do-
common mistake that people make when they look at this is they just count the amount of like triangles that are made of 1, and they're like, oh, the answer is going to be like 4. Wait. So the answer is going to be, they just count the amount of triangles that they can see, and then they don't,
Yeah.
and then they miss a lot of triangles.
So as you can see there, the number of like single triangles like Gobo was talking about is 16. But you also have to consider like all the other different combinations. So the ones that have, let's see, what, 8 triangles, there would be 3 of those. So let's see, let's just annotate this diagram. So here would be one. I'm going to change the color. Here would be one. Here would be one. And then here's the third one. And then, okay, so the next possibility is going to be
Triangles made of 4.
yeah, okay, so if we go through all of them. Oops, okay. So, dang it, this is really annoying to do. Okay, you know what, I'm not gonna draw them out, but if you were to find all of them, you can see like there's gonna be 7 triangles with like 4 smaller triangles in them. And then there's going to be one big triangle that's like the whole thing together. So finally you add all of those up and you get 27 triangles.
Yeah. I think drawing it is helpful, but you can let me here, I'll request remote. Wait,
Okay.
then oh wait, there's the marker.
Okay, here, I'll give you the marker, you can draw it.
Okay, so yeah. All right, so this is one triangle that's made of 4, and then here's the second. Then here's the third. And here's the fourth. Fifth. Sixth. So 1, 2, 3, 4, 5, and then 6. And then there's also one more as well. And that's going to be the upside down triangle, which I think someone missed. I think it was Santoshi. I think you missed the upside down triangle.
Okay.
I'm smart like Bart. Okay. Okay. So example 3, and this one you guys can solve, and I'll probably give you guys points for this one. Like probably like I'll give 5 points to the first person who gets this right, because this question is hard. All right. So 5 points to the first person who gets this question correct. How many different squares can you make by connecting the 4 dots on the grid?
You have to kind of think outside of the box for this one. Well, not really outside of the box, but just different.
It's like inside the box, but like you have to think creatively still.
Exactly. Oh no, squares are all rectangles, but all rectangles aren't squares. So don't count the rectangles.
Yeah, if you counted the rectangles, you'd be counting for a lot of time.
Right.
Charles, you're missing 2. Oh, you're missing a few.
Don't listen to him. It's not 45. Okay. So there's like 14 easy squares to find. And then there's a few more that are a bit harder. So far, no one has gotten the answer yet. And it's not 45. It's like a lot lower than 45. Don't listen to that.
Imposter.
So we'll give like 1 more minute and see if anyone gets it.
Why would you give us the wrong answer? So that I still only see 18. Oh, yeah. Remember, think inside the box. Why would you give us the wrong answer? Oh. Okay.
Okay.
All right.
I'd
Shreya
say
got
that-
the right answer.
You kind of said that Charles was missing 2 more than what he had. So
I know. I accidentally
Yeah,
said
I
that.
knew that it was 20, but I wanted to find them.
Yeah.
so then
Okay.
Well, I'll
Ask
let
Shreya. Like ask
I'll give
Shreya.
5 points to whoever can find or show on the screen all of them.
Okay, so let's go through like the easy ones, and then I'll ask Shreya to like to they can give us like the harder ones, I guess.
I meant 5 points for the person who can show on the screen all the squares. 'Cause I remember I didn't get this the first time when I was in like 6th grade. I was doing this question and I didn't get it. I only
So
found 14.
there's gonna be like 9 of those.
Well, I mean, I saw 18, so I'm smart.
4 of those squares, and then 1 big square. If you look over here, yeah, you can see like 4 of those squares with like 1 dot in the middle. Okay, and then the harder squares. Okay, we're not gonna reveal them, but Charles, can you go ahead and find like the 2 other squares that you found? Or I think I can give you
I've
remote.
already accounted for like those kind of squares. It's just he said that I'm missing 2 and I can't find the
No.
missing
You
2.
said you found 18 squares. So what were because we just listed the 14 obvious
Yeah.
squares, I guess. What were 4 of the squares that you found?
The 4 squares that I found,
You have control of the screen, I think, if you
clicked.
I
You
want
are
to draw.
controlling. How do I draw?
just like hold down.
Yeah, draw.
Hold. Oh yeah, it's working. It's diagonals.
Right. 4 squares.
Drawing circles. Okay, there we go.
All right, those are really, really great squares.
Yes, but I can't find the bigger ones. That's the problem. I can't
Let go
find
of
any
the screen.
others.
Let go of the screen so I can take it back. Like
All
don't
right.
move your mouse at all.
And then Shreya said that she found Shreya said that the answer was 20. Do you know the 2 other squares that he missed? Or
Oh,
that
I
he
think
didn't see?
1. I see 1.
Okay.
Okay, draw
Okay.
it on the screen.
Can you
I
draw it
don't
on
see one.
Oh,
Oh.
there's one.
Yeah. And then
Oh, I found them. I found it. 20, 20, 20, 20, that counts. That counts.
Okay. What about the other one? There's one
Yeah,
more.
yeah, yeah, just rotate it. I found it. Totally legit.
All right.
Yeah,
Yeah.
she didn't say that
those are
she found it, so give me 5 points now.
so those are the 2 points or the 2 squares that you can the 2 squares that were the hardest to find. All right. Yeah, so these kinds of questions also require a lot of creative
what
thinking
about
as
the-
well.
Wait, I think I see another one. Did we already account for that one or what?
Which one?
I
Can you
think
draw it?
we might have.
let me give you control of the screen. We might have done it, but it doesn't matter. I'll just okay. So
Does that mean that I can get 5 points?
Okay, am I controlling? Wait.
hang on, sorry. Okay, it's kind of messed up.
She didn't find the 20th before I found it, so technically I did it.
Wait, I still can't.
Well,
Okay, now you can.
you get a half point.
Okay,
And she
should we
gets
give
4.5
both of them,
points.
like 3 points or
I
what?
Oh, wait, how many points do I get?
You can get a half point. Sure.
Uh,
Yeah, a half.
So
But
I'm
why?
drawing on the screen. Like just hold your mouse down and drag.
man, this is so sad.
Yeah, it's not working.
Wait.
Can you like
Oh,
describe it?
What? Did you say?
are you on like phone or something?
No.
Oh, okay.
Chrome messed up. Okay, do you want to like describe it? I don't know if that would work.
Do I? Well, it's like, okay, so on the very first line, the 3rd dot,
Okay.
and then connect that to, on the 2nd line, the 2nd dot, and then the 3rd line, the 3rd dot. Yeah.
Oh yeah, like this.
Yes. Did we account for that one?
Yeah.
Like these 4 that go like that. But
Okay.
like Charles was drawing circles. So
Okay.
okay, so great job. Let's continue on. So you can see, okay, you can see like better pictures here. Those are the 6 tricky ones.
Mhm.
So I want at least 4 points, please. Since I noticed it first, she said she only found the 19th and not the 20th, so I found it first.
How about no one gets points? What about that?
That's,
It's mean.
we'll think about it. Okay, we'll think about it.
Yeah, your request has been processed. We'll get back to you in a few business days.
Okay, so practice problems. All right, how many rectangles are in the figure? And know that rectangles do include squares. Okay, so look for the total number of squares or
Squares.
rectangles.
Wait, how do we know any of them are squares?
There are some squares. There are like multiple squares, actually.
Oh, need to be counting for a while.
Yeah, this one has a lot that are easy to miss.
Is a rectangle a square? I guess.
Not all rectangles are squares, but all squares are rectangles. It's kind of confusing.
Okay.
1, 2, 3. Okay. 11 plus. Okay, I already forgot what I was counting. Yeah, there's well over 30, guys. There's a lot.
Yeah, I know for a fact that there's well over 30, but I can't see them, and I don't have any paper, so I'm just gonna not do this.
Yeah, seems like a great idea. Okay, wait. How about this time if the first person to get it this time gets 6 points instead? We'll give you time to get paper and stuff if you don't have it. It's probably a good idea to have a pencil and a paper if you're doing a math class. All right. 33. Closer. Remember, staying organized in these kinds of questions is always going to be good for you. Always, you want to stay organized when counting.
It's like my 5th time starting over counting.
Yeah, you gotta stay organized. It's difficult.
Yeah, I'd say a good idea for these kinds of questions is to keep like a table almost. I'm going to reveal the answer once someone gets it. Is it more than 37? Yes. It is more than 37. Okay. All right. Okay, I'm just going to reveal the answer now. Jivadish was pretty close, but the answer is 44. Yeah. Oh, Charles already just got it. Okay, so the answer is 44, and again, you want to keep a table of the rectangles that you're looking for, and you want to solve, and you want to add them up and find them systematically. Staying organized in these questions is really going to help you, right? These questions are pretty simple if you stay organized and if you have a little creative thinking to find the rectangles. So the amount of rectangles that are made out of 1 is going to be 11, right? So you just count the amount of like rectangles there, and it's going to be 11. So 11 plus, and then the amount of rectangles that are made of 2 are going to be 1 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's going to be 12 rectangles that are made of 2. Then rectangles that are made of 3, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. There are going to be 9 rectangles that are made of 2. And make sure that you guys see all of the rectangles. I know that I'm not drawing on the screen, but it's pretty important that you see all the rectangles that are being listed. Okay, and then we can, we don't really have the time right now, but we could go through all the rectangles, but remember, you just need to find them. You just need to find them all systematically and stay organized. That's the key to doing this question. Okay, so now we're going to move on to the next question. How many triangles are in the figure? This one may be a little easier or a little harder for you. For me, it's a little easier. Never mind, I was lying.
I think this one is a little bit easier.
Yeah, never mind. It is actually easier.
So there's only 3 like types of triangles, 3 different shapes.
Yeah. Okay. So the answer here is going to be 20. There are 20 triangles in this figure. And you just count the amount of triangles that are made of 1, the amount of triangles made of 4, and then the amount of triangles made of like, is that 9? Yeah. So, oh, you got 4 different types of triangles. What was the 4th type of triangle that you found?
Oh, wait, I miscalculated, I think.
Okay. Yeah, just make sure, just double check your work always.
Yeah.
All right. Okay. So there's going to be 12 triangles here. There's going to be 12 like small triangles that are made of 1. Then there are going to be 6 triangles that are made of 4. And then there are going to be 2 triangles, so like the big triangles. There are going to be 2 of those. The answer is going to be 12 plus 6 plus 2, and that's going to be 20. Okay.
All right, so we're running a bit behind, so we're going to skip past a couple of these, but you can feel free to like work through them when we post these slides in the classroom. Okay, so we are going to do a Kahoot.
We are doing a Kahoot. If you win the Kahoot, you get 10 points.
Again, I'm not logged in here. Okay,
First place gets 10 points, second gets 7, third gets 5th, or 5.
here, let me.
Wait, what do you do? Wait, what do you do with points?
Last time I think I gave a gift card that I just had laying around to first. I don't know what I'm going to do this time. I think we're going to do virtual cookies. So if you
virtual-
have any allergies, please let us know.
Or a virtual trophy or a virtual popsicle, whichever you want. Okay, oh my God, Kahoot is on. Are you serious?
What if Kahoot goes paid?
Okay, finally. All right, go ahead and join. Okay, you have a few more seconds to join, and then I'll start. But you can always like join in the middle too.
Wait, it's like, how many people are in class today? We have 10 people in class, so I think there should be like 10 people in the Kahoot. Or 9. Like,
All right, okay, you have 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, if you haven't joined, you have to join in the middle.
guys, it's red.
All right, so
No, it's yellow.
So this is the fundamental counting principle, which also happens to be the only principle we talked about in class today. So 2 of you picked general multiplication principle for some reason. But yeah, this fundamental counting principle, if you want to find the total number of outcomes of 2 events, you have to multiply them together. Yep, you multiply the chance of 2 independent events happening.
Wait, we divide? Oh, okay, no, we don't divide. Wait, somebody said we divide. Okay. Remember, we multiply the 2 probabilities by each other, or the 2 total amount of possibilities.
All right, not Sai is in the lead. Come on, guys, you gotta beat not Sai. Whoever not Sai is. Yeah, so this is dependent probability. So the outcome of one event will affect the other event. So like say you're doing something without replacement, like the marbles in the jar.
Oh my. Jeez. Nice. Mostly everyone got that question. That's great.
Ooh, now this one is kind of tricky because there's a specific number.
I think it's 2/3. I think it's 2/3, right? Because it's like, you know, 1,
Listen to
2,
Stop
It says,
now.
1, 2, 3, and 5, right? So it's like,
Chances
Go from-
are one is
go from
not.
the fatal mistake. Go from the fatal mistake of counting one as a prime.
oh, nobody even, oh, one person put green. Remember, 1 is not a prime number. That's where most people go wrong with this question. It's going to be 2, 3, 5, and then there's 3 possibilities over the total of 6. So it's going to be 1/2.
All right, so the strategy you can use here is like you can add 1 to all of them, and then you divide everything by 4. And then you just get the numbers from 1 to 8. So that's going to be 8 terms.
Yeah. Nice. That's good. Everyone said that the answer was 60, except for one person. So that's pretty good. Remember, it's 5 times 4 times 3, and that's going to be 60. Pictures. Okay. What if you're colorblind?
Screw you,
Yeah, I guess this question wasn't made for you.
George not found.
Like this. Okay, that's weird. Lag for a second. Oh, all of you got it right. Good job.
Oh, that's great. I was going to say the answer was red. Probability of choosing a red or green marble. Okay. Guys, the answer is blue because it's asking for a red or green. So, like, it's not going to be red or green. So it's going to be, I think, both blue and yellow are right.
Bruh. Hey guys, whenever he says it's blue or yellow, you know that it's not blue or yellow.
Exactly.
Oh, okay. Okay.
Now he's gonna use that to say the actual right answer, but it's gonna be pretty obvious.
Right. Oh, okay. I wonder who not Psy is. Guy's pretty smart.
I wonder.
Guy's pretty smart.
Oh, okay.
Oh, remember, guys, off by 1 errors. Remember, there's not 14 numbers between 3 and 17 inclusive. There's 15. And then there are 5 multiples of 3. So then it would be 5 over 15 is 1/3. Remember, off by 1 errors.
Yep. So this one is 2 over.
Oh, nice. Everyone got this one. Basically everyone. Sorry, Green.
So 15 total numbers, and then 6 of them are prime. 3, 5, 7, 11, 13, and 17.
Come on, John. You have to be a little more confident. Nice. Everyone got that question. Oh, did someone leave the Kahoot? Oh, wow. That's fine. I think someone left class, actually.
Yeah, 2 people.
What is the probability of choosing a blue ball? Make sure you don't misread the question. Yeah, I think some of you may have misread the question. It's asking for blue balls, not red.
All right, be nice now.
All right. Remember, it says less than 100. So 531 or like 315 or 135, those are not less than 100.
So here are your possibilities. 1, 3, 5, 13, 15, 31, 35, 51, and 53.
AMC always has like these little subtle things that people will miss. Remember, read the question carefully.
30% reading comprehension, 70% math.
Guys, the answer is yellow. Not Sai got the question wrong. Oh, maybe he did. Oh, he got the previous one wrong. Oh. I don't know who Not Sai is actually. I'm not doing the coot. Okay, so you guys did see the upside down triangle. Remember, the upside down triangle is the main one to see here.
And there's going to be like 10 small ones and then 3 other of the ones with 4 triangles in them.
Mhm.
All right, come on, guys. You can beat Not Sai. You can do it. Remember, squares are rectangles.
It's asking for the number of rectangles, so obviously it's not asking for squares. So remember that you want to subtract your squares.
Nice job.
Oh no. Psych.
All right, so this one, the only way you can have 2 dice that sum to 12 is going to be if you roll 6 on both of them. So and then there's a 1/6 chance that you roll 6 on like 1 dice. So you multiply that together because you're rolling 2 dice and they're independent. 1/6 times 1/6 equals 1/36. So good job. All right, podium 10.
Ooh, 14 out of 17. That's pretty good.
I'm assuming that's Charles.
Yeah, I'm Gib Cookie.
That's great.
Yeah, I screwed up on the triangle one because I didn't see the
Yeah.
upside down one because I'm blind.
Wow.
All right, good job, everyone, and the runners up.
So Not Sai gets 10 points. Means he's in the lead.
Dang
That's
it,
pretty
man.
great.
If only I got the 5 points from answering first on the other question, like I actually did.
So
It's being processed. It's in consideration. Okay.
54% correct.
Sharing this again.
wait. Oh, it's 11:30 exactly. That's great.
Yeah, so unfortunately, we're going to have to skip this fun activity, but if you want to, there are some problems on that Jamboard that you can go through yourself if you want more practice.
Yeah, I'd recommend doing them. Doing as many, like learning the concepts is good, but like if you don't do problems regarding them, your IQ or like your problem solving ability won't be grown at all. Like that's the difference between school math and competitive math. Like the math you learn in school, it's good and stuff like for concepts, but in like competitive math, you don't need to learn any more math. You just need to do a lot more problems, and you need to learn the how to solve questions, not how to learn math.
Like how to apply the things you've learned.
Yeah.
So this is your homework, the 5 problems, and we'll go over them tomorrow.
Okay, bye.
All right. If anyone has any questions, they can ask. Like they can stay and ask if they would like.